Welcome and thank you for joining our webinar today, the 5 crazy mistakes administrators make with IoT system credentials, featuring guest speaker, CISSP, the IoT Security Guy, and founder and managing principal of Fractional CISO, Rob Black. You're also joined by Beyond Trust product manager, Rod Simmons, who will cover a few points about PowerBroker Password Safe after Rob's portion, so please stick around for that. My name is Sarah, your webinar host today. A kind reminder to please submit your questions via the GoToMeeting console anytime throughout the webinar. We'll cover your questions at the end during our Q&A time. So anytime you have a question, just pop it on in. I will be monitoring those throughout. Also, today's session is being recorded. You will receive a follow-up email containing links to the recording and the slides shown here today within 1 to 2 business days from now. The slides can also be immediately downloaded by the handout section in the GoToWebinar console. You should find that on the side of your screen. Additionally, if you are attending for CPE credits with ISACA, you can locate and download the attendance verification document from the handout section as well. All right, now that that's all out of the way, let's hand it on over to Mr. Rob Black, who's going to jump right in. Hello, Rob. Please take it away.
Hi, Sarah. Thank you very much. And thanks to the Beyond Trust team for hosting me today for this webinar. I'm just going to give a teeny bit about my background. So I've been in the security space for 11 plus years, and much of that actually has been in IoT, where I've worked for a couple of IoT companies. So the information in this webinar is pretty hard earned, and I'm just gonna talk about really some of the really common mistakes that people make with IoT system credentials. Just as Sarah said, if you have any questions, please post them in the question section, and we'll do our best to address them by the end of the presentation. All right, so let's get started. So you may recognize this camera. This little guy caused some big problems a couple years ago. This is a Zhongmai camera. And it and millions of its brethren were part of the Mirai botnet attack. The consequences of the attack were actually quite severe. So the Mirai botnet brought down DIN, which is DIN's the DNS provider for lots of web properties, including Twitter and Netflix, so those were unreachable. So this was a massive denial of service attack. But this problem did not just stop there. Zhongmai and other providers had some serious issues in the sense that their devices were the perpetrators of this, and some 4 plus million devices had to be recalled. So this was obviously a very expensive problem for them. And when we look in at what were the causes of this botnet attack, we can see some common themes. So the first is hard-coded credentials. So many of these devices had credentials that were hard-coded in them. That is something that is very bad to do if you did not know that. And if you are operating devices or manufacturing devices with hard-coded credentials, you really should stop. Second one is the use of default passwords. And this one's a very common thing, especially when people buy little widgets, but sometimes even when they buy very big widgets, they use default passwords. Default passwords are known by many, many people. So anyone who sees that device is probably going to try the default password to see if it works. Now, coupling those problems with internet accessibility made things much, much worse, right? Anytime you have a device or resource on the internet, you got to have very strong password management because people can try those default passwords or hard-coded credentials. And of course, if you can't update the device, that's bad too. Now, given that this presentation is really around credentials and privileges, we're going to focus on the first 2 parts and ignore the rest, although they make things worse. There was a really good paper, academic paper on the Mirai botnet. And it highlighted a lot of it basically went through the code and really demonstrated how it worked. One of the pages, and it's right here, went through the code and got all of the credentials that were in the malware, and then it mapped it to which devices those default credentials were tied to. And you can see on the screen all the default credentials and the devices, right? When you buy a new device, you get a manual. That manual oftentimes says the default password for this thing is X, please change it. They're not kidding, and this is a demonstration of what the consequences can be. All right, so while we're sticking with kind of, we'll move from default credentials and kind of switch over to kind of common passwords. You may remember a couple months ago, the Department of Justice, U.S. Department of Justice, indicted 9 Iranians for really conducting massive data stealing of research. From a lot was from universities, but some was from other organizations with important data, intellectual property, and they stole all this data. And one of the ways in which they did it was using common passwords. So fortunately, someone actually scanned in this indictment into the web, and so you can read it. Difficult to search because it's just a scan, but you can see here there's password spraying is one of the parts of the indictment. And so with password spraying, what happens is the bad guys collect a lot of credentials. So basically they collect your usernames, they collect your email addresses, and then they try a lot of common passwords. And so that means that when you have that common password associated with your credentials, they may not be targeting you specifically, they may be targeting your organization, but they're basically trying your email address with those same common passwords for everyone in your organization, and anyone that hits, they can get into the account. So this is something that was part of this indictment. Those still 9 Iranians are still at large, presumably in Iran, but the U.S. government is moving to at least step up the pressure on Iran to stop this hacking of U.S. intellectual property. Now, in terms of common passwords, there are lots of resources on the internet that can get you these common passwords. And if you don't believe me, here's a word cloud to show that. I went to one of the sites, the top 500 passwords, edited a little bit for content. This is a family webinar, so I took out a lot of the bad words, and I put it in a word cloud. And if you see your password up on this screen, that's a bad thing. You probably should change it. But even if your password's not on here, the bad guys know to take the number 1 and put it at the end of one of these words. So there are a lot of common passwords that are beyond this list. But the point is that if you use a common password, if you use like just a name or a word or something along those lines, the bad guys are going to very easily be able to use that against you and your organization. So you shouldn't do that for you personally, and especially if you're administering important credentials on your network or your infrastructure. All right, so when talking about the 5 crazy mistakes for IoT credentials, the first one we just covered was default and common passwords. This is, this is a problem, as I pointed out in those examples, that is done again and again and again. So, you may say, well, I've heard it a million times, but, are all your passwords good, and are your coworkers at your organization, are their passwords good as well? So that's, that's something to think about. And then also think about all those devices in your organization, or if you're an administrator of IoT devices, think about all those devices out there, how many of them are using default passwords, right? And that definitely can be a problem. All right, so now let's move to the next one, and this is non-diversified keys. So we're going to get into what that means, but first we're going to do a little foray into IoT architecture, because it's important to understand IoT architecture before we start digging into the keys. So here we see a device, and the device is obviously the center point of an IoT implementation. That device will have a sensor or sensors on or near it, and may or may not have actuators. So a sensor is something that senses data. In this case, it's looks like a vapor or water sensor. Could be temperature sensor, could be any sort of thing that's detecting motion. That's a sensor. An actuator is something that also is part of IoT. An actuator is something that that you can move or engage. So, for instance, a door or an arm, or some sort of motorized thing. Okay, so that is what the device is. Now, the device either has a gateway on it or is attached to a gateway in some way, and that gateway is what's communicating with our data center or our cloud. Right, and so the idea with IoT is you have many devices communicating with the server somewhere. Okay, so now, so picture not just 2 devices here, but thousands of devices here. Now, it's important to be able to identify those devices. So how do we do that? Well, we give our devices a credential or a key, and so the device is probably going to have a unique identifier, and it's also going to have a key, and that key is the thing that uniquely identifies it. Now, what happens if the key does not uniquely identify the device? What happens if the devices are shared on the keys? So this is a rhetorical question because we're in a quiet webinar, but this is really important to think about. And the answer is multifold. So the first is if every device, and let's say you have 50,000 devices, 10,000 devices, whatever the number is, 1,000 devices, and they all share the same credentials, if any one of those devices is compromised, then the bad guy has an opportunity to compromise all the devices. So that's really bad. And then let's think about it the inverse. If someone knows that credential and that you're allowed to have the same credential for different devices, someone can create a clone device and attach it to your system and potentially do bad things. So they could send malformed data up, right? They could just send up a whole bunch of data. And they could do all sorts of things that are really gonna inhibit your experience with that IoT system. So it's very important to have a unique key for each and every device, right? That you can uniquely identify each device. And you may think that, of course I'm gonna have this, a unique key, but as we'll find, not everyone does that necessarily. All right, so up until now we've been talking about IoT in an abstract way. So let's really tie it to what market you're in. So you could be in the automotive market, or building automation, or financial, or home automation, or medical devices, or smart cities, or smart energy. And in those verticals, there's kind of two sides. There's the device operator. So in automotive, for instance, the device operator is the person who's operating the car or fleet of cars. And then there's a cloud operator. In that case, that might be the car manufacturer, right? And so for each of these vertical markets, that's the same thing. So when we're talking about IoT, here are all the different types of devices that we can be thinking about. And even if, let's say, well, this isn't important to me and my organization, if you actually work in a building, that building has lots of devices in it. And so you have probably the same types of concerns in that these things are operating in your environment, and you got to make sure that they're handled in an appropriate way. All right. So I alluded to a few minutes ago about people don't always have unique identifiers on a per device basis. And so let's go to a kind of a textbook example. So Lenovo, the laptop maker, several years ago had a piece of advertising software called Superfish on each and every laptop that they shipped out. And they cleverly used the exact same certificate on each laptop. So it was a self-signed cert. It was shipped out on each laptop for Superfish. And what Superfish would do is it would look at your web traffic and then give you relevant advertising. Well, because they shared the same secret between every laptop, anyone who had a Lenovo laptop or anyone who knew the secret from that Lenovo laptop could actually browse the internet traffic or see the internet traffic for any Lenovo user because Superfish was, the data was being sent to Superfish, but they could decrypt it because they had the private key for all that different traffic, even though it was different users. So this was a really bad mistake made by a kind of a big name manufacturer. So this type of mistake is not uncommon in IoT, and there are other examples out there. Fortunately, many of them haven't necessarily had adverse outcome, but it's quite possible. All right, so in terms of bootstrapping trust in a device, meaning when we are creating a new device or we're using a new device, what are the things we have to make sure that we do? Every device must have a diversified key. So that key, either needs to be a private key, a shared secret, or an inferred key, right? So basically, whatever the key is, it needs to be unique to that device. And you really need a scripted process that you can execute at IoT scale. And that would be at the time of manufacturing or the time of provisioning. And if we all want to think about something in our lives that does this very well, think about when you go to the store to buy a new cell phone. That cell phone always has a unique key in it, right? So basically they put a different SIM chip in each of those devices, and they're provisioning a different kind of root of trust for each of those devices. That way you don't have to worry that someone else's phone is going to ring for your telephone call. Okay, so and that's the sort of thing that you need, is some sort of very well-defined process if you are using a lot of IoT devices, and if you're a consumer of IoT devices, you need to make sure that your provider is handling that. All right, so I alluded to the fact that that shared secret thing that we saw with the Superfish was not unique to one vendor, and that's absolutely true. So Zigbee is a home automation protocol. It's used for network communication in home automation. It's actually quite popular. Good chance in your home you have one or more devices using Zigbee, or at the very least enabled with Zigbee. And to communicate between the devices in the home, it uses a network key. And that's what's used to secure broadcast communication. And it's a shared secret between every node inside the network. Now, Zigbee is based on all elements of the solution trusting each other. And most of the time, if you're a Zigbee expert, you might say, well, there's other keys. Yes, there are. But most of the time, home automation devices are operating in the least secure mode. So what does this mean? If everything in the network has the same key for the network key, that means that when you have your smart home and you have your garage door opener and your cameras and your smart speakers and your smart light bulbs, that all those things potentially are communicating together via Zigbee. And now you attach a bad smart light bulb with malware, or just maybe it was designed to be bad in the first place. All the things in your home could potentially be compromised. Bad guys can spy on you potentially, via the different devices. They could do adverse things in your home. They could use your home as a botnet. So, these are consequences that potentially could have, that could potentially be bad for you, because that device is sharing a key, the bad device is sharing a key with all these good devices in your home. Now, this is by design for Zigbee. This is not some sort of accidental mistake. This is the design thing. So when you are procuring or manufacturing or using IoT devices, we really all should be circumspect about how the secrets are being shared with devices. And it's something that's incumbent upon you to ask your provider, or if you're managing it, something for you to make sure that you're diversifying those keys in all the different ways that you can. Okay, so there's one other aspect of secret diversification, and we'll talk about it now through this fun little story. So imagine you have a great password. How do you know you have a great password? Because look at that password. It even says, I have a great password. No way anyone's going to crack that, except that you're so clever. It's such a great password. You use it everywhere. You don't use it just to administer your IoT system. You use it on Facebook and Twitter and LinkedIn and Gmail. And so now your password's in all those places. Now, what happens when one of them is hacked? Guess what? All are compromised or potentially compromised, and the bad guys can use that password knowing that it's tied to you and your account. They can try it with your other accounts to see if they can get in somewhere. So key diversification or password diversification is not just important on a per device perspective, but it's also important for users to make sure they're not using that password other places. All right, so now, so we talked about the common passwords and default passwords, non-diversified keys. Now we're gonna touch on unaccounted for credentials. So before we get deep into unaccounted for credentials, let's just think about why IoT security is different. So we just have kind of one slide to do the setting or set the stage. And there are really maybe 4+ elements of why IoT security is so different. So the first is scale. When we think about scale, you have many unmanaged devices or unmanned devices. From a human standpoint, let's say you have a laptop and a phone, or maybe maybe a tablet, or maybe a few other devices. That's manageable for one human. But if you have 10,000 devices, or even just thousands of diverse devices, it's very difficult to use kind of human-led processes to manage those devices. So lots of things need to change. Okay, the second thing is the operating environment. So from an operating environment standpoint, let's say with IT security, you're in charge of your environment and it's closed more or less. With IoT, IoT devices cross organizational boundaries. So if you're a consumer of IoT devices, those same devices could be in many other enterprises. Those devices are communicating with the same cloud solution you're using, and you don't necessarily know what's going on there. If you are the cloud provider, you're managing devices across many different organizations with many different processes and procedures and culture and kind of security concerns. So this can be very challenging to manage with such a diverse operating environment. Okay, the next one is the technology variance. So from a technology variance standpoint, if you are managing, let's say, Windows laptops, there's really very little difference between all of them. They can use the same tools. You set one set of policies. But when you have like a lot of small devices, and maybe they have constrained processing power, as a for instance, or you have different operating systems, and single management software is not going to work, or you just have mixed technology where you have all sorts of things on your network. For instance, you have a thermostat and a smart TV and everything alongside your servers and user laptops. That can make for a very challenging thing to manage. And then the final thing is on the consequence side. The consequences of IoT compromise can be quite deadly. There have been cases where there have been explosions or near explosions. I think very likely, they don't have data published, very likely from a medical standpoint, people have been killed via IoT attacks. And I think we'll probably find out in the not too distant future of some of those medical device consequences. But the point is that people can die from adverse IoT consequences. So it's something to think about in terms of all the different other aspects of IoT, right? So IoT security is different. Let's mentally jump back to the operating environment of crossing organizational boundaries as we go into how we're trying to map the IoT, the credentials for IoT. So if we have a single device, and this single device could be anything, but let's just use in this particular model a medical device. So you imagine it's a medical device on a hospital network. It's a very expensive piece of equipment. Maybe it does imaging or some sort of medical test, right? And you can imagine there's a user or set of users that are local to it that are logging into that machine and performing the medical procedure with it. There's also probably someone that's roaming around the hospital, an IT person that's doing IT management of that device. But the hospital boundaries aren't the only thing that's occurring from a user perspective, right? Because this device may need to be fixed in off hours, or maybe you need some expert help, so you have a remote admin. Maybe the device needs to be logged in remotely, again, for an off hours use case, or potentially you have some expert in another part of the hospital system that needs to log in to take a look. And then of course you might have a third-party vendor, and that third-party vendor might be logging in the device to update the software, to make some configuration changes, or just to manage the device. So that's on the user side. Now on the application side, this device is probably communicating with the local applications. Maybe there's a imaging system that the device, the image comes off the system and goes locally to something else. There may be a data store where the data from the device is stored there. And then out in the cloud, of course, same sorts of things could happen. You could have those applications in the cloud. Maybe there's a billing system where you run an MRI and it gets tied to a particular billing system. So the point is that this device can have a lot of credentials, right? And we're just talking here in a context of a medical device, but plug in your application in your environment. There can be lots of credentials tied to this device. And the question is are you aware, is your organization aware of all those credentials, and are they being managed? So, thinking about unaccounted for credentials, there can be many credentials. They're owned by different organizations. Do you have them mapped out? Do you have strong keys and passwords for all those credentials? And, are you rotating the keys and passwords appropriately? So, and that last one is going to tie into our next section, which is non-expiring or long expiring credentials. And And the expiration of credentials is a non-trivial challenge. So here we have a screenshot of the AWS IoT website. So AWS IoT is a IoT platform made by Amazon Web Services, and it's a relatively popular platform. And I took the screenshot within the past week or so. So this is a real thing. And let's look at the expiration date of the certificates that are being generated for each device. December 31st, 2049. I don't know about you, but I don't have any plans on my calendar booking that far out. So that's pretty far. And over 30 years. So that's just something to think about. If you use the default certificate that AWS IoT gives you on a per device basis, you essentially have devices with non-expiring credentials. Okay, I'll just want to point one other thing while we have this screenshot up. They recommend that each device be giving a unique certificate. So certainly that item I was talking about with the diversification of keys is something that's a non-academic thing that's definitely very relevant where folks don't always do that. But anyways, let's really think about this long expiration date, and let's think about some other credentials we may have in our lives. So what are some common credential expiration? So a typical corporate password oftentimes expires in 90 days. A newly issued SSL certificate now expires in 2 years. A typical credit card is 2 to 4 years. Massachusetts driver's license, that's where I live, is a 5-year credential. And a US passport is 10 years. So, what are the reasons that we have these expiring credentials? Well, often if there's a compromise of a credential, you're limiting your window from which that credential could be used. You could imagine, for instance, someone loses their driver's license and someone's using it as a fake ID, but within 5 years, that credential, that's going to close. There are other reasons too. So on the SSL certificates, for those of you that were involved in managing SSL certificate change a couple years ago, you probably can reason why they moved it down to 2 years. Recently they just determined that SHA-1 certificates were not secure, and folks were going to move to SHA-2 certificates. But the problem is that there were a bunch of SSL certificates out there that had long expirations. So retiring that technology was difficult. So in the case of now for SSL, the new standard is 2 years. So that way, if there is a technology change and something's going to be compromised, that window is much shorter. All right, now let's get back to the AWS IoT credential. So that one is 30 plus years. I'm sure you can think of other credentials in your life. Probably difficult to think of a credential that's going to last 30 plus years though. So definitely something to be managed. All right, now, why would you leave a long expiring or non-expiring credential? Well, it's definitely more convenient. It's difficult to manage that. IoT credential expirations can be just very difficult to manage. You have unmanned devices. Many can expire at the same time, right? So imagine January 1st, 2050. Hopefully you're not managing an AWS IoT implementation then, right? So now you have thousands or millions of devices that have just expired and you can't contact anymore. And it really requires a deliberate plan for managing those credentials. So it is a pain to manage that. However, by not expiring things, you're opening yourself up to a certain liability. All right, so now let's turn to our last topic, and that is not turning off former employee access. So, this is something that is pretty important, and yet not everyone seems to do it. Don't believe me? Look at this guy. Engineer sentenced to prison for hacking utility and disabling water meter readers. This happened last year. So this was a company that was in charge of water meters on behalf of municipalities. They let a guy go. He was ticked off. He decided he would try his credentials, logged in, and disabled water meters, and so no one could get their utility bill. So that was a big problem. He actually did it for 5 different municipalities. And let's just kind of take a look at how this worked. So here's how smart water meters work. You have your smart meter at your home or business. It's measuring water usage there. It's communicating via RF to the base station, which is nearby, and then the base station is communicating with the data center. Well, if you are a bad ex-employee, you may try to telnet into the base station. Of course, most of the time, bad ex-employees do not have the credentials to the base station. In this particular case, he still did. They let him telnet in from his home computer to the base station, and he made all sorts of weird configuration changes to disable those water meters, and caused a lot of havoc. And then ended up causing a lot of havoc for him because he went to prison for it. But the point is that this is unfortunately not that uncommon, where ex-employees can cause a lot of havoc. This is an IoT case. Fortunately, this wasn't a things go boom kind of scenario. But I'm sure for those municipalities, when they tried to send out the bill and they were unable to do it, that was still a major problem for them. Okay, so what should we do to minimize damage from that ex-employee? Well, of course, we should disable ex-employee accounts. That seems so obvious, yet it seems so hard to do it. Second one is change system passwords upon administrative employee's departure. And that one may be more difficult than you think, just because you could have tens or hundreds of system passwords, and changing them in all the places can be difficult. And you may think, well, it's not that big a deal because we have a VPN, and the ex-employee won't be able to VPN in to get in to be able to log in. However, sometimes if you don't do a good job with turning off credentials on the VPN, that can be one problem. Or secondly, and this really has happened, if your employees don't check, or if your help desk doesn't check to make sure it's a current employee, and they just re-enable someone on the VPN, and that use case actually has literally happened with kind of pretty bad consequences for an organization, that can be a big problem too. So you just want to make sure you turn things off on your VPN. And then the last one is use privileged access management, right? So privileged access management is obviously going to help in this case, disabling administrative access to all sorts of things. And actually, privileged access management is going to tie in really well with all of the things that we talked about today. So when we look at our 5 crazy mistakes, right, default and common passwords, Pam is going to handle that case. Non-diversified keys, again, you'll be able to easily diversify keys. Unaccounted for credentials, Pam can be the system of record, so it creates like really a kind of a topology of all your credentials that you have, so it helps there. Non-expiring or long expiring credentials, obviously you can manage that policy with Pam. And not turning off former employee access. With a PAM system, you just do that once and boom, that employee's off, and you don't have to worry about all the different sets of credentials that they, that they would have had access to. So, so these are our 5 crazy mistakes. As you might expect, Beyond Trust invited me to speak. Obviously, it's going to tie to something that they do that's really important. But I do think managing privileges is one of the most important things to do for your IoT system. So a privilege access management solution is a great thing to help with that. Now, where can you learn more, or where can you get more help? So we have a whole bunch of resources for you. So the first is Fractional CISO, that's my company, and Beyond Trust just released a brand new white paper on managing identities and privileges in the context of IIoT, which is Industrial Internet of Things. So that white paper is available for download. There's the link. I'm guessing Sarah's going to make that link available to all of you. In a mildly self-serving way for about 20 seconds, I'll just talk about my company, Fractional CISO. So we help companies with their cybersecurity planning, and really all sorts of things along those lines. So if you need help putting an IoT cybersecurity plan in place or doing a gap assessment, please give us a call, and we welcome speaking with you and seeing if we can help. So I'm Rob Black, and with that, I'm going to turn things over to Rod Simmons, who's Beyond Trust's product manager, to talk about some of their solutions. Rod.
Awesome, thanks. Hopefully you guys can hear me just fine. All right, so I'm going to jump in a little bit and talk a little bit about Password Safe. Is also an offering that we have that's kind of available to you for free. So I always like talking about free software because I think it's every once in a while we can get something you don't have to pay a lot for. That's great. So hopefully you guys can't see the GoToMeeting window that is tucked up in my way here, but I'm just going to move it out of my way so we can talk. All right, so when you're looking at risk, and I think Rob's done a really good job of kind of highlighting it, what we have to just figure out is where does the largest risk in our organization come from? Is it from unmanaged credentials in our environment, things that are just aging, stale passwords that are, as Rob kind of highlighted, that are kind of set by the vendor that the end user can't change? And we look at statistics all over the place. So the Verizon data breach report is something that I think everybody should be reading on an annual basis because it's always filled with good things. And we've seen a very consistent theme over the years as to the number of breaches that have happened from time A to time B based upon known vulnerabilities on systems that have existed for over 12 months or based upon credentials that aren't kind of being managed by end users. And privileged access management, when you wrap it around all that, it makes it easier for you to gain control over those devices you have out there. Sorry, I don't know why this is not changing. There we go. So when you're thinking about from an IoT standpoint and how do you go out there and attack this problem, the challenge we have with IoT is that it's one of those things that you start off very small, like with servers, and it's very easy. But with IoT, you say, okay, well, we have 400 doors in our or across all of the buildings that we have across our enterprise. So that's 400 sensors, as Rob kind of highlighted there. Then as you start to expand that out, well, we need cameras, and we have cameras at various locations in any building to cover every single corridor, every single location, every single view that we have, and those assets just continue to multiply. And over time, you're dealing with potentially different vendors because of cost structure. The problem and the complexity for any organization starts to grow out of control. Sometimes customers aren't thinking about this forward thinking. They just think about adding it on and they build it onto their existing infrastructure network. Many times, hopefully, customers are smart enough to say we're going to put it on its own isolated segment of our network, which means it has really no access to our key infrastructure like our server architecture, our end users. The IoT devices live on a totally separate VLAN, have a different egress to the internet. It's really focused on let's separate these things out. So we've seen a massive growth in the market. We actually came out with a free IoT scanner that end users can use or organizations can use to try to get their hands around what their problem is and what their attack surface is, as well as our vulnerability scanner kind of scans that stuff for you today. So whether you're thinking virtual, IoT, DevOps, or connected systems, all of those things are something that kind of sits under the umbrella from Beyond Trust that we can try to help you out address. So when you think about just from a general perimeter standpoint, from an attacker standpoint, Rob kind of highlighted this first. What an attacker wants to do is find something that's vulnerable. It doesn't really matter what it is, whether it's an end user's desktop that was poorly configured, whether it's a hardware device like a router, a switch, a firewall where you left a default password on it, or whether it's an IoT device that allows them to gain access and exploit that one box. From there, what they're hunting for is privilege, because that allows me to do many different things, most likely either move laterally throughout the organization to get to other systems, or if you're lazy, like many people are, if I get access to one SSH key that works on this device, likely I can move across devices in the environment. Likely I can lay in wait for a person with higher privileges than I have to log onto the device. Or if I'm fortunate enough where you've done integration with some authentication platform like LDAP or AD to log on, and I can grab that golden ticket and then move laterally throughout the organization. That's the goal of any attacker, is to get from where they're currently at throughout your enterprise. And again, if these things aren't on an isolated segment of your network and they live on your primary network, it's a lot harder to get around. Our focus and our goal is to kind of help you reduce that attack surface by implementing a least privilege model, monitor and audit all access as people move around. So as Rob kind of highlighted, the gentleman who came in and changed the water meters so they didn't monitor. I don't know why he didn't do that where I didn't have to pay my water bill, but hey, whatever. But the whole point is you have to monitor when people are accessing your system. So knowing that a sysadmin could leave, go home, and SSH back into the boxes, if you just put a little bit of a gateway in front of it so that in order to get onto that device and manage it, you have to go through like a password vault that will allow you to gain access to that device, which means we can fully audit that, we can fully record, we can fully see everything you do, and then more importantly, if you've left the organization and we've disabled your primary authentication account, you no longer have access. That's what we want to think about. And then be able to analyze users' behavior when they're on assets. So if we're seeing him making, as Rob kind of highlighted, very weird changes to the systems, that type of behavior should pop out in any system that's analyzing behavior to say, hey, something odd's going on here, let's address it. So, oops, I think I clicked the wrong button there. I apologize. So from our standpoint, what we've seen, we did actually a survey recently, and what we were hearing from customers when we did our survey was, for most customers, 60% of customers we talked to, they said DevOps for them is mainstream now. It's no longer that nascent thing. So when we did this same exact survey about 12 to 18 months ago, what we were hearing from customers, they were around 20, 25% were either playing around with DevOps or considering adopting it. Now we're at 60%. So we've kind of moved on past our customers really going to try to move their organizations more to this new implementation model of software. We're also seeing from an IoT and cloud standpoint that customers are really heavily embracing IoT devices and embracing moving workloads from on-prem to the cloud. Some customers are saying DevOps is great, but we only use it on-prem. Others are saying we've embraced both DevOps and moving our workloads from on-prem into the cloud. And that's kind of the transition we're seeing. But as you move that, what you're seeing is that the perimeter of your network is further expanding. Before you were dealing with internal employees, maybe partners, and then some remote employees. But then when you start to move that out and expand to saying we have DevOps, app to app, app to database, and we have third-party vendors that are accessing all tiers of our infrastructure, the complexity of trying to secure that infrastructure gets harder and harder for most customers. So from a general standpoint, where Beyond Trust kind of fits in and helps you out is that we focus in on trying to, one, deal with insider threats, because as you look at data in the Verizon Data Breach Report, whether it be to the 2017 report or you go back a decade and look at the report, every year the one consistent thing you see is that end users are almost as likely to be the people who try to exploit your organization as your sysadmins. And they do comprise a very large percentage of attacks. That's not to say that you might not have external organizations hammering away trying to get into your environment and breach and get access to data, but you do need to kind of maintain control over both privileged users as well as regular users who just, the access that you grant them in order to perform their job is something that you kind of need to monitor. So we focus in on providing a least privileged infrastructure, which I'll kind of talk to around that. Then additionally, we look at it from just a network standpoint, looking at scanning your network, understanding what's on your network, the assets that live on your network. Nothing's worse than scanning your network and saying, where did that SharePoint farm coming from? So we try to help you get a better understanding of what you have on your network, and then try to identify things that you should be concerned with, saying, oh, we haven't patched these systems. There's probably a very good reason why certain things lag in patching because of compatibility, breaking things, whatever the reasons are. Many organizations usually lag patching. And then again, if we think about what I said earlier, is that many exploits are based upon known vulnerabilities that have existed for 12 or more months. So once that vulnerability is available to script kiddies or just regular hackers, the time clock is ticking for you to actually patch it so no one can exploit it to exploit your enterprise. So from our standpoint, the way we approach addressing the problem is we go out to discover, whether it be, again, regular assets or IoT devices. We scan, identify those devices. Once we've identified those devices, we try to find the vulnerabilities that exist on those devices by leveraging our vulnerability scanner. Once we've identified either what vulnerabilities, we try to use continuous configuration management and hardening techniques to ensure that once you fix something, that it doesn't kind of slide back into a bad state for you. Then if there are built-in accounts that hopefully you haven't put devices in where you can't manage those, we actually try to gain control over those shared accounts. So rather than having 15 people who you trust that know the password, why don't we just take that password and put it in a vault and say those 15 people you trust can go to the vault and grab the password. Then we try to eliminate hard-coded passwords. So sometimes the device don't have passwords that are unchangeable. It's just that when it ships, this is the default password. There have been a number of mistakes. I think we even had one with healthcare.org, the US healthcare system, where when they first rolled out, they actually rolled out devices, I think with default passwords enabled, and it actually took their system down early on, if I remember correctly. It's just protecting from simple mistakes like that. It wasn't like they did something egregious. We were testing in the lab, everything was working fine, and we forgot. And that's just natural human nature, is to forget to go back and look at something and change a hard-coded password. Then next, making sure you enforce the proper policies around those credentials, so eliminating people who need to have direct admin rights on those endpoints, putting a least privilege model for when those users need to gain access. I talked about segmenting your IoTs to a separate network, so don't have them on the same functioning network. So that way you leverage a jump server technology. So the IoT devices live on segment A and every other thing lives in segment B. Even if at home, many of us probably say, it's so much easier for me when I'm sitting on my couch to turn on and turn off the lights if they're on the same network, because I don't have to worry about it going out to the internet, connecting back in and coming in and changing the device for my Nest devices or my Insteon devices or Zigbee or Z-Wave. It's again, segment onto another network. A little bit of inconvenience, if you will. You can still turn the lights on and off. Goes a long way for making sure that if one of those devices are corrupted, that they can't impact the rest of the organization. Because how many of you are actually logging on to every light switch you have in your house that are smart light switches to say, is the firmware what it should be? Is it actually doing what it should? Is its network communication what I expect it to be? Probably no one. And then last thing is restricting access when users get on device. So I'll make this pretty simple as we go through here really quick. So hopefully, and of course, my Mac is acting a little funny at the last second here. So we'll jump back over here, and this is actually the IoT scanner. So Sarah can make sure this link is shared with everybody, but if you were interested in just getting a test of the IoT scanner, you can just actually come over here and register yourself to get access to our IoT scanner for free. It'll allow you to just scan the network and try to figure out what you have from an IoT device and whether or not they're secure from the outside. So it does essentially a perimeter scan for you. But let's talk a little bit about password safe and how that works. So I have I got a requester user here, and there we go. I can never talk and type at the same time. So as a normal user, if I need to gain access to a device, in this case, I'll just jump over into password safe. I can have a set of accounts that are kind of shared to me, if you will. And those are my favorite accounts that I like to log into. Or if I needed to log on to a particular system, I can search for that. So if I know the system name, I can type it in. I know I have an account called key something. I can't remember what it is. These are accounts that are on one of my Linux boxes that I use SSH keys to log on with. Again, I just come in, choose retrieve. It'll show if I need to see the password, I can see the password. But in this case, because I'm just going to do a key-based logon, cancel there. Let's go here. And then I can just say open an SSH session. This will actually just do an SSH-based logon directly into the box. The nice thing about this is once I'm on the box, I can do an ID command. I never got the password for this particular account. I just clicked, it logged me directly in. I can now do what I need to do. If I needed this user to do like more elevated things, because there's a limit to what I can do, I can just invoke a least privileged product. I can get a root shell on this device. I can do an ID command. You can see now I'm running as root, and I can do what I want. I can switch directories. I think I have a scripts directory on here. Yep. Can't type today. And then from there, I can actually control everything the user can do. So if the user wanted to try to run like my installer script or whatever, because they have a root shell, they can. I can allow certain commands to run. I can block other commands the user's going to try to do right from what's inside of here. But the user never sees the password. Now, the cool thing about it, or gets access to the key. Now, once the user's out of their session and they jump back off, there's a couple things that actually happen here. One, they can come over to their active requests, look at any of those requests. Now, I chose my request for 2 hours, but once I'm done and I check it back in, that SSH key that I just used for that user to get into the system, their system will reach out to that system and re-scramble that key. So there's a new key put in place for that. And for that password that I showed you in clear text, I can just check that back in as well. And that password now, the system will reach out to that system and scramble that password. So the password is to what we saw is no longer the password, which means the user only has knowledge or has access when they do the checkout. Now I could choose not to let them see the passwords, but if I have to give them clear text because the device is off the network and they need to go look at it, the password will only be good until it's checked back in or until that 2 hour time expands, and then it's returned back to the system. Now, from an admin standpoint, the other thing that I have control over is I can look at what's going on. So let me just log in here as administrator. And I think I'm just logging in as my local admin here. There we go. So as an admin, I have kind of a similar behavior, but I'm just going to pop over here and I'll say, I can replay sessions. So when a user goes in and accesses the system, I can look for any command the user might have typed on a system. So in this case, I can just look for, did anybody invoke a bash shell? I can see there, you can see when I was in as key user, we did see me type bash. I can now click on that session, I can open it, and then I can actually replay that session and I can watch exactly what the user did. Now, of course, I didn't do anything interesting. I just typed bash and switched directories, but I can watch everything the user did. You can see from when I typed the ID command to when I typed bash, you can see an index of things that I did showing right here. So I can show output, I can show the timestamps for every command that I actually typed in, and you can watch all the behavior that actually happened for that user. So again, as Rob highlighted earlier, a user got on, they made really crazy changes, and now you have to revert that back to fix it. I from here can watch and see exactly what the user did, and with a least privilege product in place, like kind of sitting between me and the end user and the system, I could also know if they ran like the install script, what the script did. It's not enough to know that he ran that, because if he deletes it when it's gone, doesn't help me out. I can know what lives in that script and what commands were executed inside that script. So you get full control over that. And then as the user exits out of their session, you get that. But the ability to play back and watch what a user did, search for commands that might have been executed, you know who got on to what systems, what time of day, and you're able to monitor those. Now, of course, the back end of the system is actually just maintaining the credentials for the users, scrambling those on an ongoing basis, setting those credentials based upon a policy that you've defined for 20-character passwords to 80-character passwords, using, upper, lowercase, numbers, symbols, and all that kind of stuff, and just setting them based upon your organizational requirements and ensuring only the users can gain access. And then periodically, we can scan the data, and you can log and audit. Now, when a user is actually into a system, and I think I might have one more here. When a user gets onto a system, we can actually monitor, you can actually live watch the user. And I don't think I'm going to have enough time to jump into that today, but when a user gets on a system, once they're on, you can actually look at what's called active sessions. And if a user's on a system doing something they shouldn't, I can lock their session. I can terminate their session. So it's not just enough that the user gains access to the system, but it's also that I can monitor them retrospectively, but I can also monitor them actively. So I'm going to jump back over here because my slides stopped messing up for me there. So Forrester is actually in the middle of doing their new PAM wave now. We just finished it. It is a Bible of a document to write. We had a lot of fun doing it. As you see, Beyond Trust is actually one of the leaders in the PAM space. We sit up there with several other vendors. And when you look at Gartner's analysis they did in 2017, we ranked right up there as well. Gartner's redoing their analysis as well. So we had like analyst season, if you will. All the analysts are going to be coming out with their new reports, but you can see we do rank up as one of the top PAM vendors, looking at multiple analysts from that standpoint. I've already actually gone through the demo just because my PowerPoint started acting funny. So I'm going to turn it back over to Sarah because I've been going a mile a minute and I need to take a quick breath.
Thanks, Rod. I love it. Analyst season. It definitely is. So guys, let's jump into our last poll of the session, and then we'll dive into some questions. I know Rod did cover at kind of a high level some stuff within PowerBroker Password Safe, but if you would like to schedule a personalized one-on-one demo or even just a conversation with somebody to talk about any of our PAM solutions, please select yes, and then somebody will be in contact with you to schedule that demo or that conversation. If you select no, that's okay. It won't hurt my feelings, but if you are interested, if you have other questions and you want to get somebody specifically on the phone to talk about your specific use cases, please select yes. Okay, let's dive into a couple of questions. Rob, these came in for you. So if the device is behind the firewall and can only be accessed from the local network, why is it so important for it to have a good password?
Yep, so great question. Thinking that your network perimeter security is impervious is something that's probably not a great assumption in today's operating environment. As Rod just pointed out, you could have an insider attacker, for instance, on the network. You could have had malware that got into your environment, or you could have had a bad guy that kind of broke through the firewall. So if you're leaving a default password, as a for instance, on something in your network, probably there's a reasonable chance that it will be compromised by bad guys. I definitely don't rely on that outside the perimeter to secure your environment.
Rob, could you discuss what a good time frame is for password expiration?
Yeah, so interesting question. So I had that slide up of different expiring times, and the conventional wisdom until recently had been 90-day password expiration. The answer is current recommendations are probably longer than 90 days. Certainly you should do password expirations if there's a reasonable assumption of compromise. But today, if you had a very long password and you don't think there's a compromise, you could potentially leave that expiration for significantly longer. Getting that end user to change the password, oftentimes they're just incrementing a character at the end of their password, so it's probably not adding a ton of entropy to the password, and better that they just have a known password that they can remember. But interesting question. Now I would say the industry is moving away from the 90-day, but as long as you lengthen your password.
Yeah, and if I can add to what Rob said there, I think you're talking end users managing password, that 90 or more days definitely absolutely makes sense. When you're talking about like shared account passwords, I think the duration should be shorter when possible, especially if you're leveraging like a password management solution like Password Safe, where it can automate changing. It doesn't really matter how long it lives, whether it's a day or a couple hours, it can constantly be changing that password. So I'd say as long as necessary, but as short as possible.
Okay, Rob, what is so different about IoT credentials versus IT?
Yeah, so difference between IoT and IT credentials, they're fundamentally not necessarily a lot of difference. I think that point that I was making about how you have so many devices and they're unmanaged. Today you can they may just be sitting on that device for a long period of time. Someone could have logged in and potentially gotten those credentials. So it's one of those situations where you have just a lot of devices, and there's a potential for harm with maybe administrators logging in, getting those credentials, and then doing something bad in the future. So that's one of the differences. I mean, in general, I guess one of the other points is that often you are operating your IoT device and someone else is operating the IoT system. So you just kind of have different operating environments as well.
Okay, folks, it's time to wrap up. Be on the lookout for the post-webinar email containing links to the recording and the slides. About 1 to 2 business days it'll take for you guys to see that in your inbox, and it will come from communications@beyondtrust.com. A huge thanks to our experts, Mr. Rob Black and Mr. Rod Simmons, and to all who attended live today. You guys, thank you guys so much. Have a wonderful rest of your day, and we'll see you at our next webinar. Take care, everybody. Goodbye.
Thank you.